Yo, what's good, y'all? Welcome back. In this video, we're going to get a sense of what I would say in Spanish is called sufrir, suffering, pain. In other words, we're going to learn to graph this function using function evaluation by hand. Let's see how this goes. Here's a problem. We're looking at graphing the following linear function. This is the same one we saw in our last few videos. F of x equals 3 times quantity 2 minus x and quantity. Problem gives us some specific instructions. In particular, we're asked to fill out the table below using hand calculations. We're then going to plot the points that we generate on the axis provided, and then we're going to connect the dots between the points to graph this function. Here we see that we're given a table with looks like 9 different input values to evaluate. We're also given an axis labeled with the x and y values on which we're going to plot the input-output pairs that result from this. Notice in this table, the x values are going to be our inputs, and this expression for our function was called the output. In other words, every input generates a corresponding output. In the case of our first entry in this table, we see that the input value that we're looking for is -2. Now we want to evaluate the function f at -2. There's really good news here. In a previous video, we actually found the value of this function at the input -2 to be 12. We can rewrite this input-output pair in coordinate form, where the input -2, which shows up as the first coordinate of our ordered pair, is associated with the output 12. We might also notice that we've already calculated the output value associated with x equal 2 in a previous video. We said that when x was 2, f of x produced an output of 0. Once again, we know that we could write this input-output pair in ordered form. Input 2 corresponds with output 0. For all the other inputs in our table, we actually have to solve an individual function evaluation problem to fill out each corresponding output in this table. Can you see why I said that this was suffering? In my case, I would like to use the alternate description of this function because it avoids some of the confusion that might come in substituting x values inside the parentheses. Let's start at the beginning with x equal -1. Everywhere we see an x, we're going to substitute the value -1. Here I use the parentheses strategically. I know that -3 times -1 is +3. I also know that 6 plus 3 is 9. This immediately implies that f of -1 is 9. And indeed, I can fill out that entry of my table. If I write this in ordered pair form, I know that the input -1 is associated with the output 9. Let's move down to the next row in our table, which is the input x equals 0. Everywhere I see the input x, I'm going to substitute in the value 0. The value of f of 0 is 6 minus 3 times 0. I know that 3 times 0 is 0, since 0 cancels out all numbers via multiplication. 6 minus 0 is indeed 6, and I have found for myself that f of 0 is 6. I can now fill that step out in the table, and of course, I can write it in ordered pair form 0, 6. Oh my God, my hand is already starting to cramp. This is really painful. They don't pay me enough for this. Let's go on to the next one. We look at x equal 1 input. F of 1, everywhere I see an x, I'm going to go ahead and put in the value 1. We know that 1 times 3 is 3. 6 minus 3 is indeed 3. This implies that f of 1 is equal to 3. In ordered pair format is written 1, 3. We have 1, 2, 3, 4 more function evaluations to be had here. However, I want to make an observation, which is that the outputs seem to be in a pattern. Check it out. 12, 9, 6, 3, 0. Could we conjecture, I'm going to write this one in pencil because I haven't actually done the calculations, looks like every single time the outputs are going down by 3. I might guess that the next output would be -3, 3 less than the last output. The one after that might be -6. The one after that, I don't know, let's guess -9. And the one after that, -12. However, just because I made the guess doesn't mean I can stop there. I actually have to do some work to confirm. Let's move down to the next uncompleted row in our table. F of 3 is equal to 6 minus 3. Everywhere I see an x, I'm going to substitute in the value of 3. We know that 3 times 3 is 9. 6 minus 9 is indeed -3. And we fill out our table, f of 3 equals -3. Lo and behold, the guess that we made was too legit to quit. Hey. Let's move on to the next one, x equals 4. Everywhere we see an x, we're going to substitute the value 4. In the function description, we know that this is going to be 6 minus 3 times the input value. 3 times 4 is indeed 12. 6 minus 12, that would be a -6. Look what we got here. F of 4 equals -6. That's exactly what we guessed it would be, that the input 4 corresponds with the output 6. I'm so tired. Let's finish this up and put a nail in the coffin. Second to last one, we look at f of 5. Everywhere we see an x, we evaluate that value at 5. We know that 3 times 5 is 15. 6 minus 15 is indeed -9, meaning that f of 5 is -9. This is exactly what we guessed in our ordered pair. The input 5 correlates with the output -9. And we've reached the end of this very painful process. Do you see what I was talking about? A sufrir. Oh my God, sufrimos mucho ahora, ¿verdad? Now we're going to drop in a 6 everywhere we see an x. 3 times the value 6. We know that 3 times the value 6 is 18. We know that 6 minus 18 is -12. In other words, f of 6 is -12. This is exactly what we wrote in ordered pair notation. We can now use the list of ordered pairs that we've generated in this table to create a graph. Let's start at the first entry. For the x values, remember x is along the horizontal axis. We see that x equals -2. Here's the origin. We move 1, 2 to the left. And notice we're going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's my first value. So the ordered pair -2, 12 is at that point. Now if I go -1 or 1 to the left, and 1, 2, 3, 4, 5, 6, 7, 8, 9, here's my second value. If I start at x equals 0 and I move 6 up, I've got my third point. 1, 3, oh my God, we might notice a pattern. I go 1 right, 3 down. And indeed, if we were to look back at the alternative version of our function, and perhaps we were to call this mx plus b form, we see that the slope m is -3 over 1. And remember, this was the rise over the run. So we're going to rise -3, in other words, drop 3 for every 1 that we run. I can now fill out the rest of the graph using this rule. I go 1 over, 3 down. Indeed, the point x equals 2, 1, 2 has output 0. Let's keep going. 1 over, 1, 2, 3 down. 1 over, 1, 2, 3 down. 1 over, 1, 2, 3 down. The x value 5 correlates with the y value -9. 1 over, 1, 2, 3 down. 1 over, 1, 2, 3 down. And we'll just for giggles, we'll go 1 over, 1, 2, 3 down. The last step of our process of graphing this is just to connect the dots. One of my favorite games as a kid was just to draw lines in between dots. How fun. And all of a sudden, we have graphed this function on the given input. This is very painful because it takes a lot of energy. Of course, it's important to know how to do this. In the next video, we'll see how to bring technology into the mix to make this a little bit less difficult. See you there.